We have a pretty good understanding of the history of the universe from 1/100th of a second after the Big Bang until today, 15 billion years later. And it's pretty remarkable that I can say this, and it's even more remarkable I can say it and the men in white coats don't come and pull me off the stage. And I think that part of the history we have pretty much nailed down, because there are fossils and relics that are left behind that tell us that our theory is right.
Cosmology, it turns out, provides in a way a sort of testing ground for some of the ideas of elementary particle physics. We can't observe the early universe, but we can observe its consequences in the universe of today. What's it like out there?
I don't know what it's like out there. It's cold, it's impersonal, it is the machine, if you like to put it that way, that has created you. Now, by that I mean the following. Every single atom in your body was once inside a star. We are all brothers in that sense.
The trouble we're in now is that the standard model, the standard picture, is very elegant, it's very powerful, it explains so much, but it's not complete. It's incomplete, it has some flaws, and one of its greatest flaws is one which is hard to explain. It's an aesthetic flaw. It's too complicated. It has too many arbitrary parameters. We don't really see the creator twiddling 20 knobs to set 20 parameters to create the universe as we know it. That's too many. Ever since the Greeks started us on this road to understanding the atoms and the fundamental building blocks of the universe, we've had this prejudice that there's something simple underneath all of this. And 6 quarks and 6 leptons, and they're antiparticles, and they're coming in different colors and in different charges, is too complicated. And there's a deep feeling that the picture is not beautiful. And that drive for beauty, simplicity, and symmetry has been an unfailing guidepost to how to go in physics.
We haven't come to the bottom level yet. But as we approach it, we pick up intimations of an underlying beautiful theory, whose beauty we can only dimly see at the present time. We don't know that it's true. We don't know there really is a beautiful underlying theory. We don't know that as a species we're smart enough to learn what it is. But we do know that if we don't assume there is a beautiful underlying theory and assume that we're smart enough to learn what it is, we never will.
To my mind, there must be at the bottom of it all an utterly, not equation, not an utterly simple equation, but an utterly simple idea. And to me, that idea, when we finally discover it, will be so compelling, is so inevitable, so beautiful, that we will all say to each other, oh, how could it have been otherwise?
It is not as if these galaxies are expanding into a space that's already there. The view is that the space itself is expanding, carrying the galaxies with it. The expansion creates the space. It's, well, the crucial analogy first made by Eddington as long ago as 1930, just 1 year after Hubble had announced the expansion, was you can conceptualize the thing as the two-dimensional analog by the surface of a balloon. You paint dots on the surface of a balloon and you blow it up. You put yourself on any dot, you seem to be the center, and all the other dots move away from you. Now, take the air out of the balloon and look what the dots do. All the dots come toward every other dot, and if you could take all of the air out of a perfect balloon, the surface itself would go to zero. All the dots would be back at one place at one time. Every place is the center of the expansion. When you talk about this, the question that always comes, well, can you find the center of the expansion? Every place is the center of the expansion. There is no center to the beginning. Everything was back at one place, and every place and every time was identical in the beginning.
Really, the most fundamental question that we can ask about the universe is what got it started? Where did it come from? The moment of creation. And that's probably the most difficult thing to try to answer. Because in cosmology, the way we reconstruct the history of the universe is to run the movie backwards. The way we run the movie backwards is by using the laws of physics. The laws of physics that we presently know are probably good enough to take us back to within 10 to the minus 43 seconds of the bang, or the moment of creation. That's pretty close. But in order to go all the way back, we've got to get a better theory of gravity. We need a quantum theory of gravity. And I suspect that we may always find ourselves in this position, that to go that last tiny fraction of a second, we need some knowledge that we don't have. And so I think it may be a very long time, if ever, before we can answer the question that everyone would like to know. What caused creation?
It may be. Could be universe. Did not really have a beginning. And maybe that space-time forms a closed surface without an edge. Rather like the surface of the Earth. But in two more dimensions. With the suggestion that space-time is finite but unbounded is correct. The Big Bang is rather like the North Pole of the Earth. To ask what happens before the Big Bang is a bit like asking what happens on the surface of the Earth 1 mile north of the North Pole. It's a meaningless question.
If there was a creation event, it had to have had a cause. And this was Aquinas' whole question, one of the 5 ways he did to God. If you can find the first effect, you have at least come close to the first cause. And if you found the first cause, that to him was God. What do astronomers say? As astronomers, you can't say anything except here is a miracle, what seems almost supernatural, an event which has come across the horizon into science through the Big Bang. Can you go the other way back outside the barrier and finally find that answer? Why is there something to nothing? No, you cannot within science, but it still remains an incredible mystery. Why is there something instead of nothing?